Okay, class, we're about to start sections 2.5 and 2.6 over what is due this week. Now remember, with your assignments that's due this week, 2.3 and 2.4 is due, and then also 2.5 and 2.6. We already covered 2.3 and 2.4 in the previous video, so you just need to watch the previous video I sent out, and then also this video, and you will be able to do all of the learning checks for this week. Okay, so for 2.5, it starts on page 232 and it goes to 233. And the problems are 1, 3, 4, and 5. So basically, it's 1 to 5 odd and the number 4. So let me start off with number 3. I think what I'm going to do is possibly do problems 3 and 5. Okay, now for number 3, it says if S is equal to u of t, which is equal to a negative 2t squared plus 2t plus 1, and t is equal to v of x, which is equal to 3x minus 1, it says determine each of the following. Now, we have a, we have u of v of x. So basically, the first thing we would do here, we would do v of x. So v of x is 3x minus 1. So you have u of 3x minus 1. So that would take care of the v of x. Now what we have to do is, you see this u of t here? This 3x minus 1 will replace all of the t's that you have here. So it'll be u of 3x minus 1 is equal to negative 2 times 3x minus 1 squared plus 2 times 3x minus 1 plus 1. So we need to square this parenthesis here. So it'd be negative 2 times 3x minus 1 times 3x minus 1. Plus, we can multiply this here. This would be 6x minus 2 plus 1. So now, when we multiply these two parentheses using the distributive property, we have 9x squared minus 3x plus 1 plus 6x minus 2 plus 1. So we had negative 2, and in parentheses, we had 9x squared minus 6x plus 1 plus 6x minus 2 plus 1. So now we'll take negative 2 and multiply by everything in the parentheses. It'll be negative 18x squared plus 12x minus 2 plus 6x, and negative 2 plus 1 would be minus 1. So we had negative 18x squared, 12x and 6x is 18x. Negative 2 minus 1 is a negative 3. So u of 3x minus 1 is negative 18x squared plus 18x minus 3. Now that would take care of 3a. Now 3b, we have v of u of t. So we have u, it's actually v of u of t. Okay, so now we will substitute in what u of t is equal to. Now we wrote that in the previous problem. U of t is equal to this negative 2x squared plus 2t plus 1. So it'll be v of negative 2t squared plus 2t plus 1. Now we will go to the v equation, and wherever x appears, we're going to replace that with this negative 2t squared plus 2t plus 1. So it only appears one place with the 3. So let me do this here. So it'll be 3 times negative 2t squared plus 2t plus 1, and then minus 1. So let me rewrite this again. This will be a negative 6t squared plus 6t plus 3 minus 1. So it'd be negative 6t squared plus 6t plus 2. And that will be the final answer of the v of u of t. That will be the final answer. Okay, now that took care of 3. Now we're going to go to number 5. Now, number 5, it says, you read about the safety features on your brand new car. According to Consumer Reports, in a 30-mile-per-hour collision, the seatbelt locks properly about 99% of the time. In approximately 90% of these collisions, the airbag was successfully deployed. Let X represent the number of 30-mile-per-hour collisions in cars of the same year and model that you purchased. Now, A, it says write an equation for L of X that represents the number of collisions in which the seatbelt locks. So it'll be L of X, and it says the seatbelt locks 99% of the time. So we'll write it as a decimal. So it'll be 0.99x. Now we go to B. Write an equation for D of X that represents the number of collisions in which the airbag deployed. So we add D of X, and it tells us that 90% of the time the airbags were deployed. So it'd be 0.90x. And now we go to C. It says, if you suppose that every occupant is uninjured only when everything works as it should in a 30-mile-per-hour collision, that is, the seatbelts locks and airbags deploy, write an equation for S of X that represents the number of times no one is injured out of X collisions. Hint, use the results of parts A and B to write a composite function. So first of all, we will have S of X is equal to L of D of X. Now remember, L of X represents the number of collisions in which the seatbelt locks, and D of X deals with the airbags deploying. So we have this composite function here. Now D of X, like we had here in B, is equal to 0.90. So this would be L of 0.90x. So now L of 0.90x, so what we have here is wherever x appeared in L of x, that we will replace it with this 0.90. So we will have L of 0.90x is equal to 0.99 times 0.90x. Now when we multiply all of this out, that will give us 0.891x. Okay, now we come here to D. Now D, it says evaluate S of 500. So now, since we had S of 500, remember S of X is equal to L of D of X, which we found here at 0.891x. So what we would do is S of 500 is equal to 0.891 times 500. And that would give us approximately 446 if we round to a whole number. All right, now we go here to E. It says examine L of X and D of X and decide which of the safety features should be improved immediately to increase the number of survivors S of X. So basically, if you look at D of X, it needs to be improved. because the airbags fail 10% of the time, whereas the seat belts fail only 1% of the time. So definitely the airbags will need need to be looked at immediately. All right. So I think I'll go over number 4 as well. All right. But number 4 is a little tricky. But let me go over that. Okay, 4A. I'm going to draw the last table. All right. That's 4A. All right. So if we look here at 4A, well, let me see if I could get this to see if I could adjust this paper a little bit. Okay. So looking here, oh, I didn't write down the formula. Let me see, g of f of x. All right. Now we want to use these two tables in order to fill this in here. So first of all, we got g of f of x. So first we would go to f of 1, which would give us 2. So then we would take this 2 and then go down to g of 2, which would give us -3. So this would be 1, -3. Now we go to f of 2, which is -1. So we go g of -1, which is 0. Now we go to f of 3, which is 5. And then we go to g of 5, which is 1. Then we go to f of 4, which is 7. Then we'll go to g of 7, which will give us 5. Now we will go to f of 5, which is 19. We'll go to g of 19, which will give us 12. All right. Now we have 6. F of 6 is 4. And g of 4 is also 4. And that's it for A. Now for B, okay, I got to draw that table. Draw that table. All right. I just want to be a little concise with this. All right, so we have 4B in this table. We basically have X and H of G of X. And then we're supposed to have -3, -2, 0, 1, 2, and then 3. All right. So now, we have H of G of X when X is -3. G of x of negative 3 would be 4. So that would be h of 4. H of 4 would be 13. Then we have g of negative 2, which is negative 3. Then we have h of negative 3, which is 5. Then we will have g of 0, which is 9, and h of 9, which is 1. G of 1 is 6, and h of 6 is negative 4. G of 2 is negative 1, and then h of negative 1 is 0. And then g of 3 is 8, and h of 8 is negative 2. And that is your final answer here for this table. All right, so that takes care of 2.5. Now we're going to move on to 2.6, which is on page 235. Supposed to be pages 235 to 237. And the problems are 1 through 5 odd. So I'm assuming that we have a lot of different letters for this. So that's why I think that it's taking up more pages. So 1 through 5 odd. I think I'll do 3 and 5. Yeah, 3 and 5 are kind of lengthy. So that might prove to be pretty good. All right. So number 3. And it goes from A through E. So 3A. It says here, a car dealership advertises a factory rebate of $1,500, followed by a 10% discount. Let X represent the price of the car. Let f of x represent the price of the car after the rebate. Determine a rule of f of x. So we have f of x is equal to x minus 1,500. So the reason being is you will have f of x would be the price of the vehicle minus the 1,500. Now it says for B, if g of x represents the price of the car after the 10% discount, determine a rule for g of x. So this represents after the 10% discount. So g of x is equal to 0.9x. Because if you have a 10% discount, that means you're only paying 90% of what the car is worth. Okay, C. It says determine g of f of 20,000 and interpret your answer. So we have g of f of 20,000. And they want us to interpret the answer. So first of all, we need to solve this. So we would basically have g of f of 20,000. We'll put in 20,000 for x. So it'd be 20,000 minus the 1,500. So this will give us g of 18,500. Now we know the g formula, this value here will go in where the x's are. So we have g of 18,500 is equal to 0.9 times 18,500. And when you multiply that out, that'll give you 16,650. So if you write out an answer in a sentence, you will say the price of a $20,000 car with a $1,500 rebate taken first, and then followed by a 10% discount is to $16,650. Now we go here to D. Suppose the price of a car is $20,000. Determine f of g of 20,000 and interpret your answer. So we're going to do the reverse here. So we'll go g of 20,000. We know g is equal to 0.90x. So it'd be f of 0.9 times 20,000. So this would be f of 18,000. And then what we have to do with f, we'll put this 18,000 in for x here. So f of 18,000 is equal to 18,000 minus 1,500, which will give us 16,500. So the price of a $20,000 car with a 10% discount taken first, followed by a $1,500 rebate, is $16,500. Now we come here to E. It says compare the sale price obtained by subtracting the rebate first and then taking a discount with the sale price obtained by taking a discount first, then subtracting the rebate. Okay, basically they're asking you to compare which one is better. So I would say taking the discount first then the rebate is the better value. Let me see, by $150. And I should qualify that by saying for the customer, because it's not the better deal for the dealership. It's for the customer. Okay, now number 5, it says the following table gives some conversions from US dollars to Canadian dollars in October 2017. Then it says the next table gives some conversions from Canadian dollars to euros on the same day. Use the two previous tables to complete the following table for converting US dollars to euro on the same day in October 2017. Okay, I took the liberty of basically drawing the table here. Now remember, we want to go from US dollars to euros. So basically what we would do, we would go up here to US dollars, because US dollars is converted to Canadian dollars, and then Canadian dollars are converted to euros. So a US dollar is $50, Canadian dollars is $63.13. So we will go to the 63.13 in Canadian dollars. So the euros would be 42.42. Now we go to $100 US. Canadian is 126.27, which is here, and the euro is $84.85. So now we would do 250 US. Canadian 315.66. Canadian 315.66 is 212.12 in euros. US 500, Canadian 631.33. Canadian 631.33 is 424. What's that? 26 in euros. I didn't give myself enough space. But now US dollars is 1,000, and Canadian dollars is $1,262.65, which we have here, and a euro equivalent is $848.50. And we are done.